So now let us move on to the next concept, that is the Varignon's theorem of moments. So what does this Varignon's theorem of moments states? That the algebraic sum of moments due to all the forces acting on an object about any point is equal to the moment of their resultant about the same point. That means if I consider n number of forces which are acting on an object about any point, the moment produced by that individual forces or the algebraic sum of the moment produced by all these individual forces about any point will be equal to the moment of their resultant force about the same point. So to prove this, let me consider a system of forces. So this is the origin. So let me consider two forces having magnitude F1 and F2 which are concurrent at point O and inclined at an angle theta 1 and theta 2 respectively with respect to the x-axis. So let R be the resultant force of these forces and which is inclined at an angle theta with respect to x-axis, and let me consider a point A. So for which or about which we need to find out the moment of these forces. So for that, let me drop a perpendicular for each forces. So these lines are perpendicular to F1, F2 and R. So let the distance between the point and the force between F1 and A as D1 and similarly F2 and A as D2, and the distance between the resultant force and the point as D. So by geometry, again this is theta 2, this is theta and this is theta 1. So consider two forces F1 and F2 making an angle theta 1 and theta 2 with respect to x-axis respectively. Similarly, consider a resultant R of these forces and making an angle theta with respect to x-axis. The perpendicular distances of F1, F2 and R from point A is D1, D2 and D respectively. So, these distances can be written in terms of OA. So, for that let me just consider. So, this is point O. So, if this is, let me consider this as R. So, this distance is D, this is point A and this is 90 degree. This is theta and this will become 90 minus theta. So, this distance D can be written in terms of OA. So, for that consider cos theta. Cos theta is equal to, this will become the adjacent side, this will become the hypotenuse side. So, cos theta is equal to D divided by OA. So, D can be written as OA into cos theta. In a similar way, we can write it for D1 and D2. So, D1 is equal to OA into cos theta 1 and D2 is equal to OA into cos theta 2. Let us consider moment by the force F2 about A. So, moment produced by the force 2 is equal to, the magnitude of the force 2 is F2 multiplied by the perpendicular distance between the line of action of the force and the point is D2. So, again this D2 can be written as OA into cos theta 2. So, now this OA into F2 cos theta 2, this F2 cos theta 2 again is a horizontal component of the force 2. So, this can be written as Fx2. So, let me consider this as equation 2. So, now the moment by the resultant force R about A is given by moment of resultant mr is equal to, magnitude is R multiplied by the perpendicular distance between the resultant and the point is D. So, this D can be written as again OA into cos theta. So, this R cos theta will going to constitute the horizontal component of the resultant force. So, let me consider this as equation 3. So, now adding equation 1 and 2. So first equation is m1, second equation is m2, which is equal to OA into fx1 plus OA into fx2. So m1 plus m2 is equal to OA is common here, fx1 plus fx2. Again here fx1 plus fx2 will going to constitute the horizontal component of the resultant. So this is the algebraic sum of the x components or the horizontal components of the individual forces, which will going to constitute a horizontal component of the resultant. So this will become OA into Rx. So from equation 3, MR is equal to OA into Rx. So therefore M1 plus M2 is equal to R. That means the algebraic sum of the moments produced by all the forces about any point is equal to the moment of the resultant about the same point. So this proves the Varignon's theorem of moments. So now let us start with the next concept, that is resultant of non-concurrent force system. So basically what is the resultant of a force system? So resultant of a force system is the one which is having same rotational or the translatory effect as the given system of forces is having. So this can be a single force, the resultant can be a single force, a moment, or a force and a moment together. So this concept can be explained using this system of forces. So in figure 1 we have a 3 system of forces which is having a magnitude F1, F2 and F3, which are acting at different directions. So these forces can be represented by the same magnitude and in the same direction about point O along with the moment sigma m naught. So this sigma m naught is nothing but the algebraic sum of moment produced by all the forces about O. So this is sigma m naught. Now this system of forces or the effect produced by this system of forces will be equal to this system. Now each forces which are concurrent at this point can be replaced by a resultant force about the same point and the moment sigma m naught. So now this system will be equal to this system and this system will be equal to this system. Now this resultant force which is acting at a point O and the moment which is acting at a point O, these both can be replaced by a single force R which is acting at a distance d from point O. Now all these force system are equal and will going to produce the same rotational or the translatory effect as produced by the original system of forces. So mathematically the resultant can be written as square root of summation of fx whole square plus summation of fy whole square, and the direction of the resultant can be written as theta is equal to tan inverse of mod of summation of fy divided by summation of fx. So to find out this d, we have a formula that d is equal to the algebraic sum of moments about point O divided by the resultant. So here what is summation of fx? It is the algebraic sum of the components of all forces in x direction. So similarly, so sigma fy is equal to the algebraic sum of the components of all forces in y direction, and theta is equal to inclination of the resultant r with respect to x axis, and d is equal to the distance between the line of action of the force, or the resultant from point O. So now the next concept is x and y intercept of the resultant. So after finding the resultant, we need to find out its position with respect to x axis and y axis. So for that, let me consider this figure. The resultant R is acting in this first quadrant. So in that I have considered the 2 points, one is A which is on the x axis and another one is B which is on the y axis. So in order to find out the position of this resultant with respect to x axis, that is nothing but the x intercept, and with respect to y axis that is nothing but the y intercept. So now let me consider the components of the resultant, that is Rx and Ry. Rx is equal to the algebraic sum of all the x component of the individual forces, and also Ry is equal to the algebraic sum of all the y components of all the forces. So now let us consider the moment of this resultant about point O. So which is equal to moment about point O is equal to the magnitude of the force is nothing but here the resultant. So R multiplied by its perpendicular distance from line of action of the force and the point, that is nothing but D. So here we have considered the two components of this resultant force, that is the Rx and Ry. First, in order to find out the value of x intercept, I am going to resolve this resultant about point A. Resolve this resultant about point A. I am going to consider the moment of this individual components, that is, so the moment produced by this x component and about this point O is 0 because the line of action of this force and the point are in same line. So we shall consider only the y component, that is Ry, and the perpendicular distance between the line of action of this force and the point is x, and the direction is clockwise. So now we can write the value of x intercept as summation of the moments about point O divided by Ry. This Ry is nothing but the algebraic sum of all the moment produced by the y components. So similarly, so I am going to resolve the resultant about point B, and I am going to take the moment about the same point O. Now in this case the moment produced by this y component about point O is 0 because the line of action of this force and the point are in same line. Now just consider the moment produced by the component Rx, and it is producing a clockwise moment about point O. So therefore the magnitude of the force is Rx multiplied by the perpendicular distance between the line of action of the force and the point is y. Now you can write the value for y intercept as this Rx can be written as summation of Fx. So these are the values or the formula to find out the value of x intercept and y intercept. And similarly, if alpha is the inclination of the resultant force R with respect to x axis, the value of x intercept can be written as d divided by sin alpha, and y intercept will be is equal to d divided by cos alpha. So this can be this and with this. So now let us start with the problems on resultant of non-concurrent force. So, force system. So, let us take up the first problem. The first problem states that 4 forces are simultaneously acting, having a magnitude of 10 Newton, 30 Newton, 20 Newton and 40 Newton along the 4 sides of a square of size 2 meter by 2 meter. So, determine the resultant, its magnitude, direction and its distance from point A. So, the given figure is a square. This is point A. It is having a size of 2 meter by 2 meter and the 4 forces of magnitude 10 Newton, 40 Newton, $30 Newton and 20 Newton. So we shall find out the solution for this problem. First, write what is the given data so that we can solve this problem very easily. So, they have given the 4 forces of magnitude 10 Newton, 40 Newton, 30 Newton and 20 Newton on the square, which is having a size 2 meter by 2 meter. So, we need to find out the value of or the magnitude of the resultant, its direction and its distance from point A. So, what do you mean by this? First, we need to find out the magnitude of resultant, its direction and its distance from point A, that is dA, x-intercept and y-intercept. So, in order to find out this resultant, we know that R is equal to square root of summation of fx whole square plus summation of fy whole square. So, what is fx? Summation of fx is equal to algebraic sum of all the forces which are acting in horizontal direction. So, when you consider this system, there are two forces which are acting in horizontal direction. One is 10 Newton force and another one is a 30 Newton force. So, this 10 Newton force is acting towards the positive x axis, that is towards right. So, that is why it is positive 10, and this 30 Newton force is acting towards left, that is towards the negative x axis. So, that is why it is minus 30. So, which is equal to minus 20 Newton. Again consider summation of Fy, that is the algebraic sum of all the forces which are acting in vertical direction. So, that is this 40 Newton force is acting upwards, that is why it is positive, and this 20 Newton force is acting downwards, that is why it is negative. So, the value is 20 Newton. Now, that implies R is equal to square root of minus 20 whole square plus 20 square. So, what is the value of R? So, the value of R becomes, the value of R becomes 28.28 Newton, and the direction of resultant is given by theta is equal to tan inverse of mod of summation of Fy by summation of Fx. So, which is equal to tan inverse of Fy is 20 divided by 20. So, that implies theta is equal to 45 degree. So, now we shall find out what is the direction of the resultant. So, in order to find out the direction of the resultant, we have the formula that, so here we need to find out it with respect to A. So, the distance of the resultant with respect to point A, that is D is equal to summation of the moment about A divided by R. So, in order to find out this, we got the value of the resultant. Now, we need to find out the value of the moment. So, now we shall consider the moment of the resultant about point A. So, now at point A there is a 30 Newton force. This line of action of the force and the point are in the same line. So, the moment produced by this 30 Newton force is directly 0. Now consider the 40 Newton force. Again the line of action of the force and the point are in the same line. So, the moment produced by this 40 Newton force about point A is 0. Now consider the 10 Newton force multiplied by the perpendicular distance between the line of action of the force and the point is this. So, this distance is given as 2 meter and this force is producing a clockwise moment. So, that is why it is positive. Now, consider a 20 Newton force and the distance between, the perpendicular distance between line of action of the force and the point is this. Again it is given as 2 meter and this force is also producing a clockwise moment about point A. So, the value becomes So on calculating this, 60 Newton meter positive, that is clockwise. So now we shall find out the distance of the resultant with respect to point A. So for that we know that implies D is equal to summation of moment about point A is 60 divided by what is the value of resultant we got, that is 28.28. So this 60 is in Newton meter, this is in Newton, Newton gets cancelled and the remaining unit is meter. So D will become 2.121 meters. So 2.121 meters. So now we shall find out the value of x-intercept and y-intercept. So we have the formula again for x-intercept, which is equal to the mod of summation of the moment about A divided by summation of Fy. So which is equal to 60 divided by summation of Fy is 20, which is equal to 3 meters. Similarly, find out the value of y-intercept, which is equal to mod of summation of moment about A divided by summation of Fx. So on applying the mod, the negative value becomes the positive value. Again, this is also is equal to 3 meter. Now to represent this resultant, its direction and distance from point A, so we got the value of Fx as 20 Newton and Fy as minus 20 Newton. So this is point A. Since the value of x component is positive and value of y component is negative, this resultant force will going to lie in the fourth quadrant. So the direction may be either this or this, and the moment produced by this all the forces about point A is clockwise. So therefore if I consider this force, this will going to produce a clockwise direction moment, and if I consider this force, this will going to produce an anti-clockwise direction moment about point A. So as we got the value of moment as clockwise, we shall consider this force about point A. So I got the value of resultant as, what is the value of resultant we got, that is 28.28 Newton. Its direction theta is equal to 45 degree and its perpendicular distance with respect to A, that is D, this is D, which is equal to 2.121 meter. So this is x-intercept and this is y-intercept. Now we shall consider the second problem, which states that determine the resultant of the force system acting on a plate as shown in the figure with respect to point A. So, the given figure is So, this is the given figure which consists of 4 forces. One is 5 Newton which is inclined at an angle 30 degree, another one is 10 Newton which is inclined at an angle 60 degree, another one is a 14.141 Newton which is inclined at an 45 degree, and another one is a 20 Newton force which is a vertical force, and an external couple moment of magnitude 10 Newton meter is acting in a clockwise direction on this force system. So, what we have to find out? We need to find out the resultant of this force system. So, now we shall consider to find out the resultant. We know that again the formula is summation of fx whole square plus summation of fy whole square. So, first find out the value of fx and fy. Before finding this fx and fy, the given system of forces consists of inclined forces also. So, first what we have to do is we need to resolve this given force into its components. So, the force at C can be resolved into 5 cos 30, this is 5 sin 30. So, at D this can be resolved into 10 cos 60 and 10 sin 60. So, at this point A, so this can be resolved into this components, and at point B there is a vertical force of magnitude 20 Newton. So now summation of fx is nothing but the algebraic sum of all the horizontal components. So at point A there is a horizontal component, that is 14.141 cos 45 degree. Next, at point B there is no horizontal force present. At point C there is a horizontal component 5 cos 30 which is acting at the direction of positive x-axis. So therefore it is plus 5 cos 30. And at D the horizontal component 10 cos 30 is towards left, that is why it is negative, that is 10 cos 60. So the value of which is 19.32 Newton. Since this is positive, the direction is towards right. Similarly, consider the summation of all the vertical components. So which is equal to, so at point A the vertical component is 14.141 sin 45 and it is acting upwards, that is why it is positive. Next, at point B there is a downward vertical force, that is 20 Newton. At point C a upward vertical component, that is 5 sin 30, and at point D there is a upward vertical component, that is plus 10 sin 60. So the value of which is minus 16.16 Newton. So since this is negative, the direction is downwards. So now find out the value of resultant. So R is equal to square root of fx is 19.32 whole square plus fy is 16.16. What is the value of R? So R is equal to 25.18 Newton. So for this value of R, we need to find out the value of theta and the value of the distance with respect to point A. So now theta is equal to tan inverse of mod of summation of fy divided by summation of fx. So which is equal to tan inverse of the value of fy is minus 16.16 divided by fx is 19.32. So theta is equal to 39.91 degree. So we need to find the position of the resultant with respect to point A, that is why consider the moment about A. So before finding moment about A, we know that D is equal to summation of moment about A divided by R. Now take the moment about A, see the moment produced by the forces which are in line with point A is 0 directly. So what are those forces? That is 14.141 cos 45, 14.141 sin 45 and 10 sin 60. So the moment produced by all these three forces are 0 directly. So now consider at point P there is a 20 Newton force. The perpendicular distance between the force and the point is 4 meter and it is producing a clockwise moment. So that is why it is positive. Next, when coming to the point C, there is horizontal component 5 cos 30 and the distance between the line of action of the force and the point is 3 meter, and this force is producing again clockwise movement about A. Next, consider this vertical component, that is 5 sin 30. The distance between the line of action of the force and the point is 4, and this force, use the principle of transmissibility, is producing anti-clockwise moment about A. Now there is an external couple moment which is directly given, that is a clockwise moment. So directly write this as positive 10. Next, at point D, this force will not going to produce any moment, just consider 10 cos 60. So 10 cos 60 multiplied by the perpendicular distance is 3 meters, and this force is producing again anti-clockwise moment. So this value becomes 107.99 Newton meter, positive. So that's why it is clockwise. So using this, find out the value of D. So that implies D is equal to, what is the value of R? The value of R we got is 25.18 Newton. So the value of D becomes 4.385 meters. So it is 4.285 meters. So to represent this, already we got the value of Fx as positive and Fy as negative. So Fx positive and Fy negative, again the given result, the resultant we got will going to act in the fourth quadrant. So again we should consider this two forces in the direction of fourth quadrant. This is point A. So we got the moment about point A as clockwise moment. So this force will going to produce a clockwise moment. So consider this. So this is D, this is R, which we got is 25.18 Newton, and its direction theta is equal to 39.91 degree. So this D is equal to 4.28 meters. So this is your representation.